Background radiation. Background radiation refers to the ionizing radiation that is constantly present in our environment, originating from various natural and human-made sources. This radiation is all around us, but it is typically at low levels that are not harmful to human health. Background radiation is an important concept in radiation safety and the study of radiation's effects on living organisms. Here's a detailed breakdown of background radiation. Natural sources. A. Cosmic radiation. Cosmic rays are high-energy particles, mostly protons and atomic nuclei, that originate from space and continuously bombard the Earth's atmosphere. Some of these particles penetrate the atmosphere and reach the Earth's surface, contributing to background radiation. Terrestrial radiation. Radioactive elements like uranium, thorium, and radon are present in the Earth's crust. These elements decay over time, emitting radiation in the form of alpha, beta, and gamma particles. Radon gas, in particular, can accumulate in homes and contribute to indoor background radiation. Natural radioactive elements. Some elements in the Earth's crust are naturally radioactive, such as potassium-40, K40, uranium-238, U-238, and thorium-232, Th-232. These radioactive isotopes are present in the soil, water, and the plants that grow in these environments. Human-made sources. A. Medical procedures. Medical diagnostic and therapeutic procedures, such as X-rays, CT scans, and radiation therapy, expose patients to ionizing radiation. While these are essential for healthcare, they contribute to the overall background radiation levels. Nuclear fallout. Nuclear weapons testing and accidents at nuclear facilities release radioactive materials into the environment. Although the frequency of nuclear testing has decreased, remnants of past tests can still contribute to background radiation. Industrial activities. Certain industrial processes and activities, such as mining, manufacturing, and the production of nuclear fuel, can release radioactive substances into the environment. Variation in levels. Background radiation levels can vary significantly based on geographic location. Areas with higher concentrations of radioactive elements in the soil and rock formations will have higher background radiation levels. Similarly, elevation can affect cosmic radiation exposure, as higher altitudes receive more cosmic rays. Units of measurement. Background radiation is typically measured in units such as millisieverts, MSV, or microsieverts, micro-SV. A sievert is a unit that quantifies the biological effect of ionizing radiation on living tissue. The average annual dose of background radiation for an individual can vary but is generally in the range of 1 to 3 millisieverts globally. Radiation protection. While background radiation is generally not harmful at typical levels, it is essential to monitor and regulate exposure to ionizing radiation, especially in situations where radiation levels are elevated, such as in certain occupational settings or areas with naturally occurring radioactive materials. Regulatory agencies establish guidelines and safety standards to protect individuals from excessive radiation exposure. Radiation exposure and risk. Prolonged or excessive exposure to ionizing radiation can increase the risk of cancer and other health problems. However, the health risks associated with typical background radiation levels are relatively low compared to exposure from medical procedures or occupational activities involving radiation. In summary, background radiation is the constant presence of ionizing radiation in our environment, originating from natural and human-made sources. It is generally at low levels that are not immediately harmful but can become a health concern with prolonged or elevated exposure. Monitoring and regulating radiation exposure are essential to ensure the safety of individuals and the environment.